Welcome everyone to the Smithsonian National Air and Space Museum's 2021 GE Aviation Lecture Series. I am Roger Connor, a curator in the museum's aeronautics department. As consumers, we might not always think about sustainability as it relates to air travel, but the aviation industry is actively working to make your flight more efficient, more innovative, and ultimately more green. From developing new fuels and new power sources to creating more efficient air traffic control procedures, and even radically reconceiving aircraft design, innovators are defining what the future of air travel will look like. This panel of industry experts will discuss the opportunities and challenges of these new technologies and how they are working to make aviation better for the environment today, tomorrow, and in the future. Our first panelist is Mohamed Ali, Vice President and General Manager of Engineering for GE Aviation. In this role, he oversees the design, development, certification, and field services of GE Aviation's commercial engines. Additionally, Mohamed is responsible for safely operating and maintaining more than 30,000 aircraft engines worldwide. Amanda Simpson is Airbus America's new Vice President for Research and Technology. In this role, Ms. Simpson is responsible for establishing the strategic direction and funding opportunities for partnerships with scientific and research communities in North America. Clarke is a Senior Research Systems Development Engineer at NASA's Armstrong Flight Research Center, Principal Investigator for the X-57 Maxwell aircraft, and Architect of the Hybrid Electric Integrated Systems Testbed. Our moderator, Graham Warwick, leads Aviation Week's coverage of technology, focusing on engineering and technology across the aerospace industry, with a special focus on identifying technologies of strategic importance to aviation, aerospace, and defense. After our panel discussion, we will have time for questions, so please submit your questions in the chat. Finally, I would like to thank our sponsor, GE Aviation, for making this series and presentation possible. And now, I'd like to turn it over to Graham to begin tonight's program.
So, thank you, Roger, and welcome everyone, wherever you are, to tonight's lecture. So we're hearing a great deal about sustainability of air travel. And as Roger said, the world's airlines and aircraft manufacturers are responding to the concerns by accelerating their commitments to decarbonization. Just this week, at a meeting of the world's airlines in Boston, the industry committed to net zero carbon by 2050, which is actually an acceleration. But that will be no easy feat to achieve. Aviation is one of the hardest sectors to decarbonize. Today, it is impossible to fly across the US or across the Atlantic or across the Pacific without using fossil fuel. But that is changing, and it is changing surprisingly fast for an industry that's absolutely focused on maintaining and improving the safety that we've all come to expect from the airlines. So tonight, we're going to hear directly for ourselves from the engine manufacturer, from an aircraft manufacturer, and from a research agency, all of whom are global leaders in their field as they tackle decarbonization of aviation. To begin, we have GE Aviation's Mohamed Ali. Hi, Mohamed.
Hello.
So, when we hear about reducing fuel consumption and carbon emissions, all of us immediately look at the engine manufacturer and say, what are you doing about it? So what is the propulsion industry, and GE Aviation in particular, doing to help decarbonize aviation?
And we thrive on you looking at us for doing it. It actually is a thrilling moment for us. If I may start by saying it's an honor to be here. And I came to the United States as a graduate student at Cornell University. And on the airplane, and I still remember that moment, I remember the airplane very well. Little did I know that I'll actually be responsible later for the engines of that airplane. The passenger next to me, I explained my story, and I'm coming from Egypt, going on a scholarship at Cornell. And he said, what's the first thing you want to see in the United States? And I said, it's the Smithsonian Air and Space Museum. And I did go there, and it's an honor. It's an honor to see that, to see the museum, and also it's an honor to be part of this lecture today. we really believe that we are at an inflection point, and we have a noble cause for this planet and for our children and grandchildren to protect this planet and decarbonize. And we are firm believers in that 2050 goal of zero emissions, and we are doing everything possible we know how to accelerate that. And I believe it's going to take everybody working together. It's going to take governments, it's going to take technology, it's going to take the technology not just from us, quite honestly from our peers of engine manufacturers as well, and it's going to take the airframers, and it's going to take incentives, and it's going to take new technology, not just in how to make the engine and how to make the airframe and the technology that goes into that, but also in the fuel that supplies that as well. And that might be in multiple forms. It can be in a sustainable aviation fuel, perhaps biofuel. It can be through electrification, and we are big believers in that. It can be through hydrogen as well in the future. And it's going to take all of that together to arrive at that goal. Thank you for bringing this graph. This is a graph that shows the CO2 emissions and the rise of that if we do nothing. And it shows what can be done here and all the stack of efforts that need to happen to achieve 50% reduction from 2005, or which was the old goal. And as of 24 hours ago, now we have the new goal of achieving zero emissions by 2050. Technology, traffic management, new fuels, and a big expansion of the usage of these alternative fuels and technology in order to be achieving that. And as an engine manufacturer, we intend to take the lead in certainly the technologies that goes into the engine, but also the lead in the industry and working with all of our peers in actually driving all the new technologies for the future. In June of this year, John Slattery, the CEO of GE Aviation, myself, and a few of our colleagues in our partnership, CFM or Safran partnership, together with GE Aviation called CFM, and we joined together in Paris to make an announcement about a new technology development program. We are calling it CFM RISE, which stands for Revolutionary Innovations for Sustainable Engine. And in there, we are intending to change the game and make it really revolutionary. It's going to be a hybrid electric engine. The underpinning technology that drives that, we are going to be, it's going to be safe as today or safer, fast as today, quiet as today or quieter, and it's going to be 20% better fuel burn, and it's going to have more advanced materials, and it's going to have also 100% sustainable aviation fuel with hydrogen capability. The combination of all of that is 80 to 100% decarbonization. We are putting our money where our mouth is about that. In probably the most challenging period for the aviation industry, which is the past, as we all know, the past 18 months or so, we are investing and accelerating the investment in technology. This past year, we put $1.8 billion. This year, we're putting another $1.8 billion, and we are going to continue to do that and rise from that to accelerate and mature these technologies. Because we believe the future is going to have ability to fly, because that's an innate desire for humans. Do that safely, do it affordably, and at the same time as well protect the planet. Now, you might argue this is long term, but also in addition to that, if you look at our track record and history at GE Aviation, our modern engines today are 15% better fuel efficiency and consumption than their predecessors, a range of 10 to 25%. That's decarbonization. We're developing apps, and I'm a big believer in these digital technologies, in the ability to decarbonize today. And we are huge advocates of sustainable aviation fuel and the acceleration of that through incentive mechanisms for the industry. So we actually accelerate the usage of them and decarbonize. I'm going to finish by saying this. As I said, we intend to be a leader, not just for ourselves, but for the industry and for the entire planet. And we are inviting everybody to join us. And I know my co-panelists here are big leaders as well in driving and believing in that being the noble cause and North Star for us that's driving all of us. And I sat in the 1990s and I read many articles that said, oh, you know, wind energy is never gonna be cost effective, or solar, oh my God, that's gonna be way into the future. Here's what I know. Technology and a belief in it, it's gonna actually enable these inventions to happen faster than anybody would imagine. And we are believers in that, and we are going to drive that.
Thank you, Mohamed. I think it's the old adage of never say never. I think you made a really good point there about the inflection point, and I think you're absolutely right that the airline industry or the commercial aviation industry has gone through the worst 18 months to 2 years that it could possibly imagine. But I'm a journalist and I cover this, and they have continued to invest in the sustainability, the future of sustainability. I mean, it's not near term. Some of this is on the longer term, but they have continued to make commitments to invest during really the worst possible time. You'd think they would batten down the hatches and just not be interested, but they have continued to invest because I think they see it as an inflection point. And if they miss this inflection point, then they're in trouble. And I don't think they're missing it. I think they're getting it. So I wanted to move now to the future as we kind of see it, and to the research community, who is the people we look to give us that future, and in particular to NASA and to Sean Clarke, where they are laying the foundations of that sustainable future for aviation through new ways of propelling aircraft, right? So not turbines, not pistons, but electric, and particularly distributed electric propulsion, which is really taking advantage of electric to do things differently, to not have two big engines under the wing, but to have many engines that you can interact with the airplane in a way that's beneficial in synergistic ways. So Sean, you are at the pointy end of this transition. What are you learning as you try and push into that future?
Yeah, great question, and thanks, Graham, and thanks to the Smithsonian for being here. It's a huge honor. We're at NASA. We're really excited about the evolution and the improvements that the engine manufacturers are making, like Mohamed was just talking about. We wanted to also explore what you could do with fundamental changes to the aircraft, and using electric propulsion really lets you do that. So on X-57, I think we've got a video of kind of a montage of what we've been working on X-57. But we've been working on retrofitting a small aircraft so that we could really study what benefits are out there for taking the carbon burning powertrain off and taking out the fuel tank and putting in batteries and putting in electric motors, and really studying what that means for aircraft design. And so for X-57, we're building up this version that you see on this video now first, but then we're switching to this advanced version, like you just mentioned, Graham, with 14 motors on it and a high aspect ratio wing that lets us really change the way you design aircraft and reduce carbon emissions, get much better efficiency per mile of travel. And what we hope is not only do these technologies someday let you get from coast to coast or over an ocean with zero carbon transport, but I'd like to see this technology make it more accessible for you to use aircraft locally and in regional modes, so that as we start to see this technology in urban environments, you get to get around ground traffic congestion, or in regional environments, instead of driving a fuel-burning car for a 100-mile trip, make it accessible for aircraft like this to take you out in a zero-carbon configuration.
So it's interesting. I follow NASA very closely, and it's very hard for a government agency to play in a technology field that's changing rapidly for commercial pressures. So I mean, you're in electric propulsion. There's, whether it's electric vehicles or electric aircraft, it's tremendously active environment at the moment. Constant developments and everything like that. But one of the things that's interesting, and I think our audience should understand, is that when it comes to certifying that these vehicles are safe, the FAA, which is the agency responsible for saying that it's safe, needs data. And that's really where NASA, I think, and Sean, you can correct me if I'm wrong here, that really NASA's role in this is to be able to explore electric propulsion in a way that generates data that the FAA can actually use. And I mean, the example is, and I'll use this, I mean, you had a tremendous you had a thermal runaway early in the battery, early in the program at X-57. It's a fantastic thing to see. I mean, this battery just explodes. As a result of that, came a new battery design that can contain that fundamental problem that comes with lithium-ion batteries, and that moves the whole industry forward. But it takes a scientific kind of approach to the problem to be able to do that. It's not just about moving fast and being a startup and whatever. You have to generate the data that the regulators can use to guarantee that what we're doing is safe. And I think that's really the role that X-57 has taken on, isn't it, Sean?
Yeah, you nailed it exactly, Graham. That the battery technology was not something that we wanted to spend a lot of time researching, because we had this fancy wing we were interested in designing, but we found that we needed a way to take off-the-shelf lithium-ion cells and put them in an aircraft next to our research test pilot in a safe way. And so we talked to our experts at NASA. We've got a deep bench of experts, fortunately, across the country, and we brought in people who've designed batteries for the International Space Station and for our new spacecraft, and took some of those technologies and worked with our contractor team and built a battery system that you can see here on the screen that was the first of its kind, that is able to tolerate a cell going into runaway and not have all of its neighboring cells go into runaway when they fail, and do that passively. So there's no active cooling system or anything on this battery, but it lets us put this system in an inexpensive configuration on our aircraft and test it with people on board. And this technology has actually made it into the commercial marketplace. Our subcontractor ES Aero and their battery manufacturer EPS are actually selling this battery and are able to help other aircraft designers use this technology to put electric propulsion into the air now.
Yeah, it's fascinating to watch. So we're going to move on now to Amanda. To thank you, Sean. We're going to move on to Airbus and Amanda. So Amanda, the thing I find fascinating is that, we've already said that, that when we talk about efficiency and fuel burn, we always tend to look at the engine manufacturer and say, what can you do for us? But Airbus, when it comes to this sustainability and decarbonization, Airbus is really taking an end-to-end approach. It's really looking at everything from the fuel to the vehicle configuration, to the propulsion, to the infrastructure. I mean, can you talk us through really how Airbus views this?
Well, thank you, Graham, for the question, and of course, thank you to the National Air and Space Museum for having us here tonight. I will say that first off, following Mohamed and Sean is really tough. Because they talked about a lot of the innovation, a lot of where things are pushing, and the truth of it is we've been working on this for a long time. The aircraft that we're flying today are 50% more efficient than the aircraft only 30 years ago. right? And that's because we've been working on things like, improving the aerodynamics. Whether, the sharklets at the end of the wings, just looking at fairings and lots of different things around the aircraft. And of course, a lot of that efficiency comes from the engines and the advances that Mohamed was talking about. And it's also such things as just looking at the materials. The aircrafts are lighter today. And even by making them lighter, they're stronger and they're safer. So there's a lot of activity that's been going on for quite some time. But the next 50%, to get down to net zero, that's going to be really, really the hard part, right? And it's going to be the new engines. It's going to be the new technologies. But when we're talking about net zero, we're talking about net zero across the entire life cycle, the entire ecosystem of aviation. And that is a huge challenge. So some of the things that we're looking at are, how do we deal with air traffic management? How do the aircraft, once they are, it has people on board and they're sitting ready, waiting to push back from the gate, how do we make sure that it's efficient, just taxiing across the airport so that we're not waiting in line to take off, so the aircraft can climb right up to their most efficient altitudes and begin their descent when they are at a minimum power setting and land on an airport, don't have to circle around. And when they land, that there's a gate open to them. Amazing things that are happening with big data and artificial intelligence and bringing that autonomy and expertise actually also into the cockpit. We're talking about new engines and new fuel systems. Those are going to make a big difference. And of course, we have 40,000 airliners out in the fleet, actually more than that. And you have to figure out what you can do with those, because those are going to be flying for decades. And so the sustainable aviation fuels, whether they be from bioproducts or industrial or residential waste, to actually reuse that carbon to make fuels instead of using petroleum coming out of the ground. There's a lot going on that we have to look at. And one of the big things that we've been pushing, a little over a year ago, we went public with our concept for a zero emission aircraft. That would be an airplane that does not put out any carbon dioxide, nitrous oxide, carbon monoxide, sulfur oxide, all the things that are greenhouse gases, by actually burning hydrogen. Hydrogen, the most elemental substance in the universe, that when you burn it, either in a combustion in an engine like the turbofans that the Mohamed was, or in a fuel cell to create electricity for an electric motor, something along the lines of what Sean was talking about, the only thing that comes out of the tailpipe is water vapor. So we finally went public with this a year and a half ago. The intent is to have an aircraft in service by 2035. What you see on the screen are a couple of the different concepts we're exploring. We're not doing 3 airplanes, but these are things that we're working with our customers, the airlines. We're talking with our suppliers. We're working with the researchers. We're working with engine manufacturers and say, what is the art of the possible? And we're in that technology maturation stage right now, where we are developing the technologies. And our intent is, in the next few years, around 2025, we will make an announcement. We will say, this is the design. We'll have launch customers, and we will actually start developing a brand new aircraft. It'll take advantage of those new technologies, those new materials. So even while we start talking about the fuel system and we talk about the propulsion system, these are brand new aircraft. They will have the high aspect ratio wings that Sean talked about to take advantage of increased aerodynamics. They will have new materials so that the aircraft themselves are lighter. And, how do you, the whole infrastructure on the ground handling, using liquid hydrogen rather than the petroleum-based kerosenes that we have today. There's a tremendous amount of synergy that's going on in the aviation industry in conjunction with all this that's going on in the other transportation industries, automobile, long haul trucking, marine. We're all getting together to work this problem so that we have a solution that'll make for a cleaner planet in the future.
I think you make a very good point there. I mean, we tend to look at aviation as an isolated system because we are in the aviation industry. So, but the fact is that these trends are far wider than aviation. I mean, to talk about hydrogen in aviation, it's not in isolation. It's an energy transition that's underway that aviation can take advantage of. So it is not just aviation; it's everybody. So we're going to go to the questions here, and I just wanted to. I sense as a journalist, I'm always looking for an angle on things, but I always sense a kind of a creative tension between Airbus and hydrogen and the engine manufacturers, and So Mohamed, what's your view of hydrogen? How is it doable in a 2035 time frame? Can we go hydrogen by 2035?
Yeah, yes. Now, there are a couple of things I want to say first on the electrification. To finish that story, we are actually very grateful that we are partnering with NASA. NASA just awarded us a program to collaborate and partner together to develop a hybrid electric and electric propulsion system for the future. And we intend to demo that together with NASA and other partners by the middle of the decade. And we are super excited about that. And it's going to bring a ton of innovations for doing that. You think of hybrid electric, probably the engine or propulsion, the same way you would think about a hybrid electric for a car, in which you load different parts of the engine in the most efficient way during different phases of flight. So we are super excited about that partnership, and it's part of the technology pillars that we have that will enable that sustainability. Hydrogen, you said there is tension. For us, I don't see that. I see that we see hydrogen by 2035. Can we actually solve these technical problems of developing a propulsion system and an aircraft? Yes. There is a lot more to be done, though, around that. There is, as Amanda said, there is a whole infrastructure that also needs to change. In full transparency, that's not cheap to do. There's a lot of innovations that need to happen for that. So are we going to see it in can we see something in 2035? Perhaps. Can we see it at the full scale across the entire industry? I would sit today and I say, probably not. But are we working on it to mature the technology and understand it and be ready when it's ready to be done? You bet. I think that's part of our responsibility as a player in this industry to be able to mature that, understand it, and enable it for the future. And as I said, I think maybe a few moments ago, we read many articles, again, about the renewable industry in which people said never going to happen. And as you said, Graham, never say never. And as responsible leader in this industry, we're just going to have to mature that technology, working with our partners, develop it, understand it, and be ready. And it's going to happen at the right time when that infrastructure is developing. And I think I gave you a sense of what that timeline is going to be. Are there things that can happen and should happen ahead of that? Absolutely. Like as we talk, SAF, sustainable aviation fuel. Perhaps we all can agree that more penetration of SAF is a lot easier and a lot more doable in the short term. And we just have to be continuously thinking short term, medium term, and long term, and have a spectrum of technologies that intended to achieve that. So we enable that noble cause that we just talked about. The beauty of hydrogen is that there is no, as Amanda said, there is no CO2 coming out.
Also, there are ways to use hydrogen in aviation that don't require you to burn it in the engine. I mean, we have sustainable aviation fuel. We have synthetic fuel, which is hydrogen and captured carbon dioxide, which can produce a fuel at the end, which is essentially net zero. So,
and that's another huge play. That's another huge enabler. What we call power to liquid.
Yeah.
Is what you talked about. And that's another key technology enabler for the future. And I think we have to think of it as it's not going to be, as I mentioned at the beginning, it's not going to be one solution. It's going to be a spectrum of solutions.
So Amanda, so Airbus at one point in time was kind of heading down the hybridization route, hybrid electric route. It then switched to hydrogen. Is hybrid electric still a pathway for the Airbus wants to look at? Or?
Well, absolutely. I think, when we were looking at straight electric hybridization, we found out some issues that we needed other answers to. I mean, one of the things is when you start down a path, maybe sometimes you find out that that path is not leading you to the destination. And we had already been working with hydrogen, and we realized that bringing hydrogen on board actually solves some of the hybridization problems that we were seeing. So actually, part of the zero-E solution is hybridization, right? They are those type of engines that Mohamed talked about, where you're actually maybe combusting hydrogen and at the same time using electric boost for, say for the climb phase. The electricity coming from a fuel cell would also run all the systems on board the aircraft. So hybridization is absolutely part of the plan. And let me clarify one thing. When we talk about entry into service by 2035, that doesn't mean that everywhere around the planet you now have hydrogen aircraft. It just means that somewhere an airline is starting to use them in regular service, and over time we will produce more aircraft. They will be used by airlines all around the world, but that's going to take quite a bit of time.
Yeah, we're hearing about this concept of hydrogen valleys, where you've got regions where hydrogen they lead the transition to a hydrogen economy, and therefore it's there for the infrastructure's in place, and you can fly out and back from a hydrogen valley airport and still do what you're going to do. Sean, I mean, your focus is distributed electric propulsion, but presumably you are agnostic to where that electricity comes from. I mean, whether it comes from a turbo generator or a fuel cell or a battery, you're enabling the use of that power in a form that benefits the aircraft broadly.
Absolutely. Yeah, there's a lot of opportunity for hybrid solutions, for hydrogen power, for all electric vehicles like X57, and we can benefit. We can see aerodynamic improvements by electrifying and converting different parts of the powertrain. X57 is just one of many projects at NASA. We have a graphic about the community concepts of a lot of the different research programs. NASA is studying hydrogen power. We're studying different vehicle configurations. We're really excited about how this technology is going to not only enable the large transport aircraft that we've been talking about here, but also smaller aircraft that get you to those big airports so you can take those big trips. And it's all got a lot of promise. And I think the key here is we're not going to see improvement in the technology until we all start investing in it. And I think that's what the three of us here are really excited about is moving the ball down the field a little bit and seeing these improvements.
Yeah, so as I think Mohamed referred to it, NASA this week awarded a couple of contracts for a thing called the Electrified Powertrain Flight Demonstrator, which is to put a hybrid electric, a powerful megawatt class hybrid electric powertrain into the air. So GE has one, and magniX has one, and the idea is to actually get these very large, hybrid electric systems into the air. Airbus, Rolls-Royce, etc. in Europe have got one running on the ground. I mean, but we are moving that way. And as Mohamed said, the key here is that when you hybridize, you can keep your turbine engine. You can stay on that path of improvement that the turbine engine's been on for decades, and now you can play games with the turbine. You can adjust how you use that turbine because you've got electric boost or you've got electric load sharing and all those sort of things. It's interesting. Once the engineers get their teeth into this, it's amazing what they come up with. So we're going to move over now to to the audience questions. And here's one that I know I ask many, many times. So Mohamed, 1980, sometime around 1980, unducted fan was flying around. I think it went to the Farnborough Air Show on the back of a MD-80. What is different? How is Rise different to that 1980s unducted fan?
Oh, a whole lot. And since 1980, we've been advancing technology. But here are a couple of 3 breakthroughs. 1980 vintage, and even up to maybe a few years ago, we had 2 counter-rotating fans. You need that to achieve the aircraft speed that we all like. The problem with 2 counter-rotating fans is, as you can imagine, very complicated, large containment structure that needs to happen in case of a fan blade out, etc. The breakthrough we had is you don't need that. You need just 1 fan, and behind it 1 static structure. And what enabled, and obviously now the complexity is gone, it's a lot smaller, and we can now achieve a lot smaller containment structure. And now we can achieve the same speed of the aircrafts that we all came to love and use, and then at the same time achieve the efficiency and at a lower noise. And what enabled that is a huge development and investment we've been making in the past few years, leveraging what's called graphical processing units, GPUs. Supercomputing, we are one of the largest this program has been one of the largest supercomputing facilities users in the world. And we are not just able to analyze using modeling and simulation and advanced computations, but also design, because of that speed of processing that has been enabled in the past several years. And that enabled us to find a validated solution that we actually validated in wind tunnels, working with our partners in government agencies also, and validate that we can achieve the noise, achieve the speed, and achieve the same levels of safety. That is the breakthrough that is quite different than everything that you heard about back in the 1980s. The other thing is also the core of the engine. A lot of new materials are going into that, ceramic matrix composites, which enables ceramic parts, which enable lighter weights. We have that already in LEAP, which powers the A320neo as well as the MAX. And we have it also in the G9X that's going to be powering the 777X, the Boeing 777X. We are expanding the usage of that. There are advanced other concepts of using additives and advanced cycles inside that core, all together combined to give us these new efficiencies. Think of it this way. Electric cars are not new. They have been here since the time of Thomas Edison, who's also the founder of this company. You can say the same thing about unducted fan. The electrical cars you have today are not the same as when Thomas Edison was around. That's exactly the difference between Rise and what we had in the 1980s, is a lot of work that went into these technological breakthroughs that will enable the future.
Thank you. So Amanda, batteries and hydrogen are energy carriers, right? They're not a source of energy. They're a way of getting energy from one place to another. So you use electricity to charge a battery, you use electricity to create hydrogen. That power then gets transferred to the vehicle. When you look at that whole equation, how does it come out? I mean, is it still a good way to power an airplane?
You know, I think it's a great point, because when we think about jet fuel, you know, whether JP8 or Jet A or kerosene or even gasoline in a car, that is an energy carrier, right? The petroleum, the oil that comes out of the ground, is this black goopy stuff, and it goes through a refinery and it goes through a whole process to make it that nice, clean liquid that we then put into our aircraft or into our automobiles. So that is indeed a very energy intensive process right there. When you look at hydrogen, it is the most abundant element in the universe. The problem is it's not free floating easily in our atmosphere, so you have to extract it. The easiest way to extract it, the simplest, is to extract it from water using electricity. And what we see in the future is that electricity would come from renewable sources, whether that be solar or wind or geothermal, etc. And the nice thing about that production of hydrogen through electrolysis is it can be done in large facilities, and then you move the hydrogen to the point of consumption at an airport, for instance, or you build smaller facilities at the airports or wherever it's going to be used and bring the electricity there, or produce the electricity right on site. So it's actually, yes, it's an energy carrier, but it can be very, very clean.
Right. No, it's a good point. And I do also think that we should be comparing apples and apples. If we're going to talk about carbon reductions, we need to treat fossil fuel the same way as we treat hydrogen or batteries. We need to go from whatever is it, well to wake and whatever. We need to take everything into account and have a level playing field when we're talking about that. So, here's a question. This week, as we talked earlier, the world's airline industry committed to net zero by 2050. Now, they had previously had a target of a 50% reduction in carbon by 2050. We knew that they were working. They were already said they were working on a faster target because that 50% by 2050 didn't meet the Paris Agreement targets. Net zero by 2050 does. So I want to ask, do you think it's actually feasible? I mean, Sean, you understand electric propulsion technology like nobody else does. Do you think it's feasible to get to net zero by 2050, and how much will electric play in that role?
I think there's a lot of work to do there, but it's not in a vacuum either. So we've got the energy grid is switching to cleaner emissions. We've got, like you say, the Paris Climate Accords. So I think if we can focus our effort and find these opportunities for convergent technology, there is an opportunity to get there. There's going to be a lot of work, and I think a lot of what our research has shown is it may make sense for certain missions sooner than others. So a lot of the missions that people need to fly are not the 5-hour flight from coast to coast, but are shorter flights. And most of the time when I get on a A320, I'm not sitting there for 5 hours. So there's going to be a lot of opportunity there to roll this technology out, and I'm really excited about it. And I think we're going to see a lot of new aircraft designs that take advantage of this new marketplace.
I do think it's very interesting because I think we have to see some changes in business model as well as changes in technology. We have to have airlines that are willing to have shorter range airplanes or whatever. Mohamed, net zero by 2050, is it actually achievable?
Yes. Is it hard? Yes. But the reason we are here is because it's hard. The reason we are putting the money and the resources and the technology innovations, it's because it's hard. Because SAF doesn't have enough feedstock. It's because hybrid electric is not easy. It's because hydrogen is difficult. That's why we're here. That's why I actually keep saying this is the best time to be an engineer. Because the world is going to need these innovations. And we can do it. We can do it. We are here because we can do it. Hard? Absolutely. Do we thrive on that? Of course.
Amanda, Airbus, I think anybody would agree Airbus has taken a very aggressive stance on grasping the sustainability nettle. Is 2050 an achievable target in your viewpoint? And what do we need to get there?
Yeah, I think what has changed, right, from when we were saying, 50% reduction by 2050 based on those 2005 emissions, to now when we're saying we're going to be able to get to net zero, is that partnership that has sprung up in the last several years with the governments of all these nations who are now saying, you know what, to meet the climate accords through Paris and others, we have to be very aggressive. And so they're passing legislation, putting together policies that will develop sustainable aviation fuels, that is putting research into power to liquid, that is working on developing a lower cost hydrogen, that is putting effort and technology into the research in advanced aerodynamics and new materials. So that has been the change, that the rest, whether it's aviation or the ground transport community, that we're all moving together faster than we were when that original commitment was made. And so, yes, it is going to be achievable, but that journey of 1,000 miles begins with a single step, and we're off and running right now.
Actually, you make a very good point there about this cooperation. There's a question here that relates to aviation versus automotive, and one of the things that we kind of forget is that nobody lives in isolation. You are going to compete with automotive for access to renewable fuels capacity. You are going to compete with automotive for access to renewable electricity. You're going to compete with other industries. So is that cooperation, Amanda particularly, is that cooperation expanding beyond the normal boundaries of aviation?
Well, absolutely, because today we don't compete for electricity. We don't compete directly for, say for hydrogen, which is today used in the production of petroleum. But what it really means is that it's a great signal to those energy companies who are now part of the solution, that the demand is going to be there in the future decades, and they're coming, to grips and, looking forward to producing the demand. And they know it's a question of economics, and they're working hard to push the cost down.
So, Sean, I mean, electric aviation is getting its start with automotive technology. Do at some point or other, do we have to stand up on our own 2 feet as aerospace and say we need to push this in a direction that automotive's not going to push it? We need to start pushing battery technology beyond what cars want or whatever.
Yeah, absolutely. Battery technology, motor technology, inverters, all the electric powertrain devices. We had a big boost from the automotive industry, and that's where, for instance, the X-57 vehicle took a lot of the technology. But we found that there was not always a great match between aircraft requirements and what you need for a high-performance automobile. And so that's one of the really exciting things is as we're identifying those challenges and figuring out what the technology needs to evolve into, we're able to take those lessons and get them out to Airbus and to GE and bring them to industry standards groups and really describe with test data from NASA what we're learning and where we need to take this technology. And so we're getting there, and we're learning a lot of lessons as we build this and demonstrate these technologies.
So Mohamed, GE writ large is an energy company in many ways. Are you seeing synergies across GE, things that where you can actually work together in, whether it's wind turbines or
no doubt,
or whatever?
No doubt. It's give you some examples here. As a matter of fact, the motor generators that we are collaborating with NASA on for that hybrid electric flight that's going to happen in the middle of the decade, our sister company, you can see a picture of that here. In our sister company, they make generators, both in our wind turbine business and our gas turbine business. And they actually have great expertise in assembling these machines and designing them. So we absolutely leverage that. The other part is hydrogen. Little known fact, perhaps, that we have our land-based gas turbines in our GE gas turbine business, and also from our aeroderivatives for land and marine applications. We have extensive history of millions of hours on building hydrogen at different fractions of hydrogen. So certainly we're not starting from scratch here. We are building on all of that experience to be able to leverage it. And obviously we're going to have to take it a step further. So that's a great position to be in. I actually go to visit our research center in upstate New York very frequently. That's where a lot of these innovations are happening. And the best thing they do is they actually take the innovations from one part of the company, add to it, and leverage it in other part of the company, which is a great position to be in that we're leveraging. That picture that you just saw about that motor that's being assembled, and it's actually going into an altitude test facility in collaboration with NASA. Several years ago, it was multiple times bigger than that. And with the technology that we have been working on, it's that size. There's 1 megawatt of power that's packed in this tiny package here. That's the power of technology and innovation.
Yeah, no, never underestimate what you can do when engineers get their teeth into something. So I'm going to wrap up now and say I think that it goes back to what Mohamed said right at the beginning. Inflection point. This industry actually understands what is at stake and is working to respond to that, and working, I think, in a way that it hasn't maybe always worked in the past. It's working across manufacturers, across suppliers, across sectors of within aerospace and outside of aerospace. And I am seeing, as a journalist, I'm seeing tremendous change and progress. And it's only been relatively short number of years that we've been this focused on the problem. I have high hopes, actually, for the next few years. So I want to just close by thanking our speakers, Mohamed Ali of GE Aviation, Sean Clarke of NASA, and Amanda Simpson at Airbus. And I also want to thank the sponsor of this lecture, GE Aviation, and the Smithsonian and the National Air and Space Museum, which is a cool place. So I'm going to wrap up at that point and say thank you very much for staying with us.